Standard computer processors are manufactured in pieces. They are cut from circular wafers of silicon, snipped into tiny identical rectangles, and packaged individually. To train modern artificial intelligence, engineers wire thousands of isolated processors together across giant data centers. But physics presents a hard limit. Data has to leave one chip, travel across copper wires, and enter another. That physical journey creates a microscopic delay known as latency. In 2016, Andrew Feldman and his engineering team realized the easiest way to solve that delay was to eliminate the journey entirely. Their solution was to stop slicing the silicon. By keeping memory and computation on a single, uninterrupted plane, data moves in fractions of a nanosecond instead of crossing a crowded room. The result is the Cerebras WSE3. It is a single, massive chip, roughly the size of a dinner plate. It packs 4 trillion transistors into an area 57 times larger than a standard NVIDIA H100 GPU. For decades, the semiconductor industry considered a chip this large impossible. Silicon wafers naturally accumulate microscopic defects, which usually ruins standard chips. Cerebras built extreme redundancy into the hardware, automatically routing data around flaws to maintain a continuous circuit. Concentrating maximum resources into one massive, high-stakes package solved their hardware problem. It also became the exact blueprint for how they would run the business. By mid-2024, the AI industry's priority expanded. The bottleneck shifted from training new AI models to inference, the process of actually running those deployed models to answer user queries in real time. Inference relies heavily on memory speed. Because the wafer-scale design keeps its memory directly adjacent to its processing cores, it avoids the data traffic jams that slow down traditional hardware. This chart tracks the speed at which systems generate text, measured in tokens per second. A standard high-end GPU generates roughly 130 tokens per second when running Meta's Llama models. In independent benchmarking, the Cerebras system pushed that output past 2,600 tokens per second. Generating words 20 times faster proved that a single massive piece of silicon could outpace standard hardware architectures for latency-sensitive applications like voice assistants and reasoning models. That speed advantage positioned the company for an IPO in late 2024. But their initial public financial filings revealed a glaring vulnerability. Their customer base was as densely concentrated as their hardware. 86% of the company's revenue flowed from entities tied to the United Arab Emirates, anchored heavily by a single AI firm named G42. Relying on one foreign ecosystem triggered immediate alarm in Washington. U.S. regulators feared advanced hardware could bypass export controls and reach restricted markets through intermediaries. A grueling 20-month national security review by the U.S. government effectively froze the company's momentum, forcing Cerebras to formally withdraw its initial public offering. One microscopic defect on a silicon wafer requires built-in redundancy to prevent total failure. Cerebras had no such redundancy in its revenue stream. To survive the failed listing, the executive team did not build a broad, diversified roster of small clients. Instead, they sought out an even larger, singular partner to replace the UAE revenue. In January of 2026, they secured a massive master agreement with OpenAI. The deal gave OpenAI exclusive inference capacity, ultimately valuing the contract toward $20 billion. Paired with a commitment from Amazon Web Services to deploy the chips in its own data centers, the OpenAI contract gave Cerebras the financial weight needed to return to the public market. On May 14, 2026, the company successfully debuted on the Nasdaq. They raised $5.55 billion, pushing their opening day valuation to roughly $95 billion. Wall Street eagerly bought into the recovery. But beneath the top-line numbers, the company had simply traded one heavily concentrated risk for another. On their second day of trading, the market delivered a reality check, dropping the stock roughly 10%. Delivering on massive contracts requires extreme upfront spending. With a $2.2 billion lease for a new Canadian data center, Cerebras must burn through its IPO cash aggressively just to build the infrastructure its giant clients demand. This approach sits in stark contrast to NVIDIA, which controls over 80% of the market by selling to thousands of different clients, all locked into a proprietary software ecosystem. The long-term viability of the wafer-scale chip now depends on flawless execution. Cerebras has to convert its OpenAI and AWS deals into actual revenue before tech giants like Google and Microsoft finish building their own specialized hardware to close the speed gap. To challenge a monopoly in the modern AI economy, a hardware startup cannot rely on safe, gradual diversification. They have to put all their chips on the table.